Hello, student. So, in the last few class, we have seen about several basic things of tree, and we have seen the introduction of binary tree and implementation of binary tree, and we have introduced binary search tree, but we didn't see the implementation of binary search tree. And in the following class, we'll see the implementation of binary search tree. Moreover, we have seen how to traverse a tree, and no, we didn't see the implementation of how to traverse a tree. Today, we'll see. We'll describe the traversing of a tree or binary tree in details with some more examples, and we'll see some implementation of how to traverse a tree in a different way. So we have seen three different ways to traversing a tree. We'll see the implementation of those traversing. Okay, so far we have seen that we can traverse a binary tree. So when basically traverse a tree, we basically visit all the nodes of the tree. So the motivation of traversing a tree is that we want to do several operations. So probably we want to apply some operations on each node. So we traverse, we visit each node, we apply those operations, then we go to the next node, then we apply that operations, and so on. So probably these operations could be printing data. This operation could be doing evaluating expressions, or apply some operators. So whatever operation you want. If you want to apply the same operation on each node, then probably you need to visit the whole tree. So when you need to visit the whole tree, you must follow some way. So otherwise, it would be not good efficient to traversing a tree if you don't follow any algorithm. So in last class we have seen that there are three different way to traverse a tree. Is called pre-order, in-order, and post-order. So pre-order means that you have to visit the root node first, then you need to traverse the left subtree, then you have to traverse the right subtree. And in order means that you have to traverse the left subtree first, then root, then you go for the right subtree. And post order is you traverse the left subtree and right subtree, and finally you go to the root node. So the order basically depends on where you are placing the root node, where you when you are visiting the root node. You always see that left subtree always come before right subtree. Here you can see the left subtree, right subtree, left subtree, right subtree, subtree, right subtree. But the root node is changing in each order. So visit root node here before left and right. That's why it's a pre-order. Visit root node is in between left and right. That's why it's an in order. And visit root node is after left and right. That's why it's a post order. So we have seen this algorithm also in our previous slides. So basically you can see this order. So visit, this is a pre-order, that's why we are visiting first, and after visiting we call the pre-order again, and we call with the left child, and we call the pre-order with the right child. This pre-order is a recursive algorithm, so it's called itself again and again, and it calls with the left child again, left child once, and then it will call the right child. Then this is one examples. We have seen some examples, but this is a better presentations of showing the pre-order examples. So for examples, you have a tree A B C. So A B C, so what is the way to print A B C? So pre-order says that you have to visit the root node first, then left node, then right node. So that's why is print the root node first, A over A, then left node B, and then B, and right node the C and C. So left root, left, right, root, left, right. So this is the pre-order. Now if you have a the larger tree, then what, how do you print that ones? You have to print the root node first, A, then you go for the left one, B, then then you go to, so when you come B, so you think you see that this is another subtree, so you print B, root of this tree, so you print B. So after printing B, then you go to the left subtree. After coming the left subtree, you see that this is the another tree, so you print the root of this tree, D. Then you go to the left side. When you go to the left side, you see that this is another tree with now children. Then you print the root G. So once you have finished all those things, so you see that you printed already left root. So this is now duty is to print right, so you print H. So you done with all those things, and you already printed this one. That means you print left subtree root. Now you have to print this one. When you come to the right side, you see that this is another subtree, so you print root first, E. So you E over here, there is no any left, so then you print right, I is the print. So you see that you print this one and this one. That means you print all left subtree of this node, and you already printed this one, so you have to go to the right side. So when you go to the right side, so you see that this is a tree. So you go to the you print the root first, C, then you go to the left side, and after coming the left side, you see another tree, and this is the root of this tree. You print F, and there is no any left, so you go to the right side and you print J. So after printing J, you have seen that you printed everything. So this is the how you are printing pre-order. So how you are printing pre-orders. So basically you print root first, then you go to the left side, and if you find that another tree, then you print the root first, and you keep continue until you find the child, you find the leaf of that tree. Then when you find the leaf at that tree, that means you printed left side, then you go for the right side. So this is pre-order expression tree. We have seen one expression tree, in our previous class. So this is an expression tree. We have discussed that we can have binary expressions in our programs, and we can represent that binary expressions in a binary tree. So this is one binary expressions in a tree. So basically this is give the prefix of an expressions. So we have discussed in our previous class, in some few class before that, what is prefix, infix, and and postfix. So this is binary expressions. We can print our prefix expressions. This is infix expressions that was represented in a binary tree. So we can convert our infix expressions into prefix expressions by reading the pre-order way. Say for example, so we if you want to print prefix, so in a pre-order, so you print divided first, this is a root, then go to the left side, then you print the multiplications, go to the left side, you print the plus sign, go to the left side, you print A. Then after printing A, then you print B. Then you're done with these things, then you come this side, you print minus. Then you go to the left side, you print C. Then you go to the right side, you go print D. So you have done all of this, and you done all this one also. Then you go to the right side, plus sign, then you go to the left side, print E. Then finally you print F. So this is the prefix expressions of infix expression. You should try to find out what is the infix expressions, how to represent. So for example, if we write the infix expression, it should be A plus B, that in parentheses, then that should be multiplied by C minus D. So this is one expressions, and that the result of this divided by E plus F. So this is the infix expressions. So in order, we have discussed in order expressions in our previous class. In order is basically that you have to do the operations on node in between uh, mm, left child and right child. So you can see that the algorithm says same things. If t is not null, if tree is not null, then you call the in order functions recursively with the left child. Then after that you visit the t to do some operations, and then you call the in order functions recursively with the right child. So you can see that visiting a tree in between left child and right child. So if you want to print in order, so we know that a root should be printed in between left and right. So and pre-order was something printing root before left and right, so that's why it was a b c. Now you can see that the result is b a c because we are printing left first, then we print root, then we print right. So b a c, so left root right, and root is in between left and right, so root is a is in between b and c. Now if you go to the larger in order examples, so if you want to print this data in an in order way, so you have to start with the root. So we cannot print root first, we go to the left side, then we go to the left side, then we go to the left side, so we print g because there is no any left side. So we print g, then that is a left, then we print root of this tree d, then we print right of this tree h. So after printing whole subtree, then that means that we printed all the left side of these nodes, so then we can print the root of this node. So b, we print b. So after printing b, we print a left and we print in root. Now we need to go to for the right side. So after we coming here right side, we see that this is a tree, then we try to find out whether there is any left or right. No, there is any left, so we print the root, then we print the right. Okay, so after printing right, we have done the whole subtree, and now we can print a now. So after printing root, then we go to the right side. After coming to the right side, we have seen there is another subtree, so we go to the left side first, and we see that there is no more left side, so we print this f. Then we go to the right side and we print j. So then after printing left subtree of this node, then we finally print c. So this is the in order way. So how in order way we can we can print all the data of this tree. The basic thing is that in order that you have to print the left side first of any subtree, then you print root, then you print the right subtree. So after finishing the subtree, so you will see that you have done with the left subtree, then you go to the root of that you go to the parent of that subtree, and you find the same, do the same things again and again recursively. So these are the things that we just done here. So this is the some pictorial view, so you can see that. So it started with the g, d, h, then b, then e, I, finally a, then f, I, c. So these is the projections, how in order happen. Now in order arithmetic expressions, so we have seen in our pre-order that using the pre-order way, we can print the prefix of an expressions, and similarly we can print infix expressions using our uh, in order traversing way. So if we follow the in order traversing way, this is in our arithmetic expressions tree, expression tree. So we start with the here, then we go to the left side, then we go to the left side, then we go to the left side. So we found that this is the leftmost node, so we print a over here. After printing a, then we print root of this subtree, then we print right of this subtree. So after printing these things, we are done with the left subtree, then we print root of this subtree, So this is a multiplication. Then we go to the right side. After coming to the right side, we print the left of the subtree C. Then we go to the, we print the root. Then we go to the right side D. So after finishing whole left subtree, we go to the root of this whole tree. Then we print root. Then we go to the right side. After coming to the right side, we see that there is a left. So we go to the left and we print the left. And after printing left, we print the root, and finally we print the right. So after following the in order way, after printing these things, we see that is basically produce, you know, arithmetic infix expressions. So there is no any parenthesis over here, so that's why it's sometimes it's may confuse that which expression would be evaluated first. So but it creates infix. You can see that a plus b multiplication c minus d divided by e plus f. So this is a infix expression, so we can create a infix expressions by traversing an expression tree in an in order way. Then finally we have a post order traversal. Post order traversal saying that we have to visit our node or root node after visiting left child and right child. So since it's coming after left and right child, that's why it's called post order. So in this algorithm we can see that if tree is not null, then we are calling the post order function recursively with the left child. Then we call the post order function recursive method recursively with the right child. Then we finally visit that node. So this is a post order traversal algorithms. Now if you go to this simple small tree, so we know that the root should come after left and child. That's why it should print b first, then c first, then a. Left right root, left right root. So that's why it's printing b c a, b c a, left right root. So this is the post order example. So we are printing root after left and child. So this one is a left, this one is a right, so this one is a root. That's why it is coming after left and right. Now if you go to the bigger examples, bigger tree, so larger tree, so this is the how we can print. So if we start with the root, so we need to print the left first. So we go to the left side, we see that this is another root. We go to the left side, we see that this is another root. We go to the left side. After coming there, we see that there is no left, so we print this one. Then after printing this one, we need to print right before root. So we print age. Then after printing left and right, we can print root of this subtree. So we print d. So after printing left subtree of this tree, so we go to the right side before printing root. We after coming here, we see this is a another root of this subtree. So we try to print out left, but there is no left, so we print right. After we print I, then finally we print root of this subtree. So after printing left side and right side, then we can print root of this tree b. So after printing b, we finish all whole left subtree of this node. So we can go to the right side before printing a. So after coming here, see, we can see this is another root. So we go to the left side. After coming here, we see that this is another root of the left subtree. So we try to go to the left side since there is no left. So we print the right before the printing root. So we print j. Then finally we print root of this subtree. So after printing this subtree, we found that we printed all the left subtree of this node. Then we try to find out right of this subtree. There is only right, so we print root c. So after printing this whole subtree, so this is the right portion of this node, and we already printed left portion of this node. So we are done with the left and right subtree of this node. Then we can print the root a. So these are the things, this is the result. So how post order happen, you should print the left child first, then go to the right child, then after finishing printing left and right child, then you can print the root. So similarly, prefix, infix, the post order, gives that postfix expressions from an expression tree. If we traverse in a post order, so it's basically give you the postfix expression. We know what is postfix, infix, prefix, that we have covered in our class few class before. So if you want, if you traverse the tree and print the print all the data in an post order way, then you can produce a postfix expression. So let's try with these things. We start with here. So since it's a post order, we go to the left side, then left side, then left side, we print A, then we print B, because left and right, then we can print root plus sign. So this is a B plus sign. So after finishing this one, then we go to the dash side, we print C D minus. So C D minus. So after finishing this and this, then we can print this one multiplications. So after finishing this sign, so before printing this one, we print this one. So we print E F plus. So you can see E F plus. After finally these whole things and whole things, then we can print the divisions. So this is the way how we can print a postfix from a expression tree uh, using the post order way. So these all about the three different way we have seen in details with the example. Let's see some implementations. So we'll try, this is example that how we can print or apply any operations on each node, using pre-order, post-order, and in-order fashions. So since it's a tree, so tree must have some node class, because they maintain some node. That's why we have a node, the class node, and it has three different members. One is data or key, another one is two different childs. Those are the node type, left child and right child. Then we have a constructor. If we give some item, this is the data, and initially data will be that item assigned by that item, and left and right child will be null. So in the binary class, we create a binary class with a root node null. This is an empty tree. Then we have a implementation of pre-order, print, post order. Then we have print in order. Then we have print for pre-order. So these are the three different methods that basically we will try to cover in this program. So pre-order, that we know that basically print the node or do the operations. So this is not pre-order, this is post order. So let's start with the post order. So if we want to apply post order says that you have to traverse the left child first, then right child, then you go for the root. So that's the post order. That is happening in this method. So before going for this one, we need to check that whether node equal to null or not, so tree is empty or not. If tree is empty, or you finish all those things, all the nodes, then you have must some you know mm, so breaking point of your recursive function, so that called base case. So this is your base case. So if you don't have base case, then you cannot terminate the recursive functions. That's we already know that. So since this is a recursive functions, it's called print, post order again and again. So that's why you have some base case. So the base case basically says this, that check whether tree is empty or not, or tree you are done with the all nodes in the tree. So that time you will reach your base case. If node equal to null, then it returns. Otherwise, if tree is not null, or you are not done with all nodes, then you print post order with the left childs. You call the print post order with the node dot left, basically left subtree, and then you call print post order with the node right subtree. So after finishing left and right, then you do the uh, operation on the node or root node, that basically, sorry, printing node data. So basically it's printing the data of the node. So since this is a post order, that's why it's doing operation on left first, then right, then you go to the root, root and node informations. So for in order, in order, we know that so visiting root should be in between left and right, and it's doing the same thing. It's checking whether node is null or not, whether tree is empty or not, or whether you are done with all nodes of the tree or not. So if you are not, then our tree is not empty, then you go for the in order with the left child. After finishing left child, you do the operation on the node root. Then after finishing the root, then you go for the right child. So these are the things. Then you can see that the operation on root happening in between left and right childs, left and right childs. I will upload this code into originate in resource folder, so you'll find all those code in resource folder. It's not only this code. I'll upload all those codes that I have done for this course. You'll find those coding file in the resource folder. That will be helpful for you as a reference. Now go to the pre-order method. Pre-order method says that you have to visit root node before left and right, and you are doing the same thing. You're doing the same thing. You check whether tree is empty or you are done with all nodes of the tree or not. If not, or tree is not empty, then you print the root node first because it's a pre-order. Then you go for the left child, then you go for the right childs. Okay, so these are the three pre-order informations. Then you have some main functions. In the main functions, you create some you know some tree. So your tree root equal to has some one value, one data one. Then you create left child, then you create right child, then you create left of left child, and you create left of right child, right of left childs. So this is some manual creations of a binary tree. After manual creation of binary tree, then you can traverse the whole tree. So you can, so basically if you're if you compile this code, so if you compile this code, let me so let's compile this code. Okay, java c binary tree dot java. So now you run these programs. So this is the results of pre-order, in-order, and post-order. You can see this, the arrangement of the data is different. One was 12453, the in-order is 42513, and post-order is 45231. So there are three different orders, so it's depending on the pre-order, post-order, and in orders. There are three different traversal, and these are the implementations how we can implement a pre-orders. Now we'll see some more things of tree. So let's start with some new slides.